Hi everyone, welcome to Chatter Overflow episode 4, and we are delighted today. We're talking about threats to computer systems and networks. So we're going to go through some of the kind of fundamental threats, and we believe this may be helpful for anyone who is studying GCSE, computer networks.
Yeah, I think it's network security.
Network security.
Network security in GCSE. This should help you because this is part of the syllabus. We've structured this to be part of that syllabus. So hopefully you can just watch this one video and
learn some stuff. So we have a few ideas on what we're going to talk about, and we're going to talk about different forms of threat and attack, and I think we're going to start with brute force.
Okay, so let's start with the simplest one, brute force. What is it? It's a way of attacking a system where you either know none of the things that you need to get in, or you know parts of it. So if you've got an authentication system, such as a username and password, and you know the username, but you can't guess what the password is, you would use a brute force attack. This is the easiest way of finally getting into something. So it's essentially like if you get one of those bike locks and it's got like 1, 2, 3, 4 as like the combination wheels. It's like trying every single one of those combinations until you get in. Another way of sort of putting this is if I had to guess your birth date, right? Yeah, your date of birth. I could just take random guesses at it, like sort of January 3rd, 1972, or something like that. But a much simpler way is to try every single combination, every single date, every single month, for every single year. And it takes a very, very long time, especially if you're born in 2012 or something. It would take a long time to go through that. But you can obviously band it because obviously anyone born in 1900 probably isn't alive now. So you can bring it forward a bit. So probably 50s onwards. But the point is, although it takes a very, very long time, you will succeed eventually. And this is the trouble with like password systems is if your password isn't particularly long, it doesn't take long to go through all of those permutations. So brute force is always effective. It will just take a really long time sometimes. And that's where a lot of our encryption, it kind of plays into that. So encryption can always be broken. It's just going to take a very long time to do that. So that's why encryption is quite safe, because we try and use really big numbers, but brute force is always effective.
So it's basically the name says what it is.
Exactly.
You're just not
using brute force to do it.
Yes.
It's the reason you'd use it is because if you don't have the capability to guess what the password is or break it in some other method. And this is really, really important on any system that you have that requires authentication. You're going to get into it somehow using brute force, unless you put into place things that stop brute forcing. So, for example, if you try the wrong passcode on my phone, for example, 3 or 4 times, it locks you out for longer and longer and longer until it locks you out for a very long time. So unless there's a mechanism to stop brute forcing will almost always succeed.
Cool.
I think that covers brute forcing about as much as you can, really.
Yeah.
It's a very small subject because it just does one thing.
Yeah, it's pretty simple. So I'm going to talk about denial of service and distributed denial of service. So denial of service, you've probably heard of, certainly you'll have heard of distributed denial of service. A denial of service is when one computer is used, or one device is used to basically flood another computer or system with so much information that that target can no longer cope with it and it ceases to function. It's overloaded. And a distributed denial of service is essentially the same thing, except distributed is important. It basically means lots of computers or internet connected devices, systems are all pointing their traffic at this target, and the target can't cope with the demand, and so it ceases to function. It's flooded, it's overloaded. So denial of service, distributed denial of service can be, it's not necessarily malicious. It can sometimes just happen because the system that's being that's receiving all of the data or the traffic is not built to withstand the amount that it's receiving. So if it can't cope with the demand on it, and that sometimes happens by accident. So, for example, when I was a teenager, some of my friends were big Take That fans, and I remember them trying to call the hotline. So I've just dated myself. But anyway, I remember my friends trying to call the hotline to get Take That concert tickets, and they were really annoyed because they were ringing and the hotline basically wasn't working because so many other teenagers were also ringing at the same time to try and get Take That tickets.
All 7 of them.
Take That were quite popular. So that's that was kind of accidental. The system just wasn't built to withstand the demand. But denial of service, distributed denial of service are also used maliciously. And it's an availability attack. It's not about stealing information. It is about just literally making something not be able to function. And we have an interesting example of a distributed denial of service from a few years ago, the DIN, or some people call it DINE, but I call it DIN, the DIN DDoS from 2016. And this was when, I think it was October 2016, when basically a large part of the internet, lots of websites for people who were in the US and for a lot of people in Europe, they couldn't get to the websites. The websites were not functioning. And it essentially came down to the DIN DDoS. So a DDoS that was affecting DIN. DIN is a DNS provider, domain name system provider. So essentially what DNS does is when I type in google.com, DNS will link up what I type, the name that I type in for the website, with the actual IP address. So we don't have to remember complicated IP addresses. We just have to remember what the website is called, and DNS does that linking up. So actually, Chris Ensor spoke about DNS in episode 2 of Chatter Overflow. So go and check it out.
Watch that.
But it's basically part of how the internet functions. And so when DIN was affected with this DDoS, so were all of the websites that they provided DNS for. And it transpired that it was the Mirai botnet behind this DDoS. And Mirai, this was basically an Internet of Things DDoS. So people's home cameras, people's home routers, internet connected devices in people's homes were compromised and used. And this was huge. It was absolutely massive, basically the biggest DDoS that we had seen up until that point. And so it kind of sounds like this is huge, right? This is what nation state, a lot of people were speculating at the time. It transpired, no, this was a few teenagers who were in the US and they were trying to target a competitor's Minecraft server. So they were trying to affect the functionality of a competitor's Minecraft server to try and, give themselves a competitive advantage. And they accidentally caused this massive DDoS that had huge impact on DIN. I think it was using around 100,000 endpoints to carry out the attack. So absolutely massive, very interesting case study.
That was a terrible day for the internet. It really was. And Minecraft also.
Yeah, it shows loads of things. It shows the vulnerability of some of our internet infrastructure, among other things.
Yeah, it's crazy. Okay, so next up, malware.
Yeah,
talk about malware.
Big one.
This is a massive one, so bear with us. Right, so malware is malicious software, right? So it's a portmanteau of malicious and software. So you get normal software and you get malicious software. Malware comes in two flavors, right? You get wormable and non-wormable. That's essentially the big sort of split of it. Wormable means that it can self-replicate and move on to other targets. Non-wormable is its specific thing, and it stays on your computer. It doesn't go anywhere else. It just infects you. And then there's different types of malware. So you get Trojans, you get spyware, you get ransomware, etc. Right? So Trojan is basically a virus that is hidden within another thing. So whether it's you download an image or a file and it's got a virus in it, then that's a Trojan. Very much like the Trojan horse of Greek mythology. Go and read that if you never have. Then you've got spyware. So spyware infects your machine, generally your browser, and it allows access to like your camera and your keyboard, your clipboard, anything like that, so that they can spy on you, get your details, maybe blackmail you, or even worse, for sexploitation reasons, record you and then try and get money out of you that way. And then you have what's the other one I just said? Ransomware is where the computer gets infected and it encrypts all of your data and then provides you a way of decrypting it in exchange for money, right? So I was trying to think about some of the bigger ones we've had. The Morris worm was the first one. That was the first wormable virus. That was in 1988. And it infected 6,000 computers. Now, that doesn't sound a lot, especially nowadays. I think some companies have more than 6,000 PCs on their own. 6,000 PCs at the time represented about 10% of the internet. There's only about 60,000 computers on the entire internet at that time. So massive, massive impact from that one worm written by William Morris. Then you had, I'm trying to think of some other examples, the I Love You virus. The I Love You virus was a little bit more malicious, right? So you basically had an email, it came in. Viruses weren't really well known back then. So you'd receive an email, it had the subject line of I love you, here's a little love note, and you'd click on the love note to open it, and it would run a piece of script that would basically delete loads of stuff on your system, and that was really, really bad. In fact, I think at one point it had the Guinness Book of Records for the most virulent virus or something, or most damaging virus, something like that. So that was really, really bad. And then you go on to more targeted malware. So Stuxnet is a really great example of this. Stuxnet was a very specific piece of software written to destroy something, and it's good as an example because it crosses over into the physical realms as well. So a little bit of background on this. The Iranian government were trying to make nuclear bombs, and to make a nuclear bomb you need uranium. So you have to enrich the uranium. I won't go into the physics of that, but it's quite an interesting subject on its own. And in order to do that, you spin uranium gas in a centrifuge, and it purifies it. So what some government people got to was they built a piece of software that was delivered via USB stick, so not over the internet, via a USB, and it got plugged into the Iranian network. They infected these centrifuges. So basically the centrifuges ran faster than they should do, and they basically just obliterated themselves because they couldn't handle the speed. So it destroyed a lot of physical stuff from this one piece of software. So malware can be very, very dangerous because it can cross into the physical world now.
Yeah, and I think there's loads of things about Stuxnet that's really interesting. It's from 2010. One thing that was very interesting is that the people who designed Stuxnet intended it to have a very specific target. Yes. And we can assume they didn't mean for it to go beyond that target, but it did. It got out onto the internet, and it has been reused. The code has been reused elsewhere in other attacks. And it's a really interesting example of how sort of weapons on the internet are different to kinetic ones, because the collateral damage, unintended consequences can kind of spill out more, whereas kinetic ones have kind of got more targeted as time has gone on. Yeah, obviously, you still get collateral damage with kinetic ones, but
that's a great example, actually. Yeah, kinetic weapons have got more and more sophisticated, and now it's like some of them it's just one single person from miles away. You can never quite explain how bad the collateral damage is going to be on.
You can't necessarily predict it or contain it in the same way. So yeah, Stuxnet's super interesting.
Yeah.
So
there's books on it. Go and read this.
Yeah, Kim Zetter's
book is a really good book on that.
Really interesting videos about it online. So lots of resources to read about Stuxnet. It's a great case study to explore.
Yeah. So
malware's pretty bad.
Pretty big. You can also look into reverse engineering malware if you needed to. There's ways and methods of doing that to figure out all of the fancy methods that malware writers are using to get around a lot of protections. It's a really fascinating subject.
And malware has to be delivered.
Yeah.
You have to get malware in. And there's, of course, different ways of doing that. So FC talked about Stuxnet and the USB. They used a USB for that because the network was air-gapped. So the idea behind an air-gapped network is that it shouldn't touch the internet, of course. Often they end up that they do. But if you've got an air-gapped network, then attackers will be finding other ways to get in. And with Stuxnet, they did that via USB. I certainly don't know. I don't know if it's known quite how the USB got in. Was that a malicious insider? I don't know. Or were they socially engineered?
Well, so there was a really interesting bit about how they worked out what devices they needed to get onto. Was there was a tour of the Iranian facility by the Prime Minister, who showed them around, and in the background of the video was one of the devices, and they managed to work out what it was.
So a little bit.
So, like I say, it's very
reconnaissance.
fascinating.
So yes. Anyway, totally ruined my exceptionally natural segue there, where I just so happened to mention social engineering. Oh, social engineering, you'd say. Maybe I'll tell you more. And you also mentioned Trojan and the Trojan horse, which also it's from mythology, but is an example of social engineering. So social engineering is basically manipulating people to give access to information, to a place, to give access to money, or to just hand over money. It's basically tricking people using well-known psychological tricks and things that are well established to be able to confuse or manipulate or coerce people. Social engineering has risen hugely. Obviously, it has basically been around as long as humankind. People tricking one another to do different things, and there's loads of interesting case studies from history around social engineering and how it was used in warfare and how it was used in industrial development of countries. But as we, of course, have got the internet, as we've got more connected, as information has got more connected, and as we've focused on the technical defenses, what that's meant is cyber criminals have realized it is easier, faster, cheaper, quicker, less risky, more likely to be successful if they socially engineer us. So how do they do it? Well, obviously email, phishing emails, and as time has gone on, more spear phishing emails, targeted, more sophisticated phishing emails have been the mechanism of choice. But it's, of course, not just carried out over email. Social engineering is basically, you can be socially engineered over any way you communicate. So however we communicate as human beings, that can be hijacked by social engineers. And so this means WhatsApp, this means social media, this means phone calls, this means video calls even. There's a really interesting case where silicon masks were used in social engineering last year. Very interesting. So basically, it's about taking advantage of how we communicate as people and manipulating someone, often by posing as someone else. So this could be your bank, it could be your boss, it could be your best friend. It's basically an attacker posing as someone that you trust or someone that you think is legitimate, and then you hand over information or money or access to the fraudster. So the purpose essentially is to get someone to do something that they shouldn't or wouldn't ordinarily do. And social engineering for a lot of our clients has been the #1 threat for a while. And they have increasingly seen this move. So it's not just email based, but we've seen some really interesting and clever and conniving social engineering attacks over social media and over things like WhatsApp. But we've got a really good, or bad, depending on how you look at it. We've got an interesting case study of social engineering just from last week, of course, with Twitter. I'm sure it won't have escaped anyone's notice watching this, that Twitter were compromised. This was last week. So if you're watching this video at a later date, July 2020, and we all started to notice last week that high-profile Twitter accounts were sending out tweets that were cryptocurrency scams. And it was pretty obvious from the start that this wasn't the compromise of individual Twitter accounts. So often with something like that, people maybe have used weak passwords, they haven't got 2FA set up.
Brute force.
They've been the passwords have been brute forced, or they've been socially engineered into giving away their passwords. But it was pretty obvious from the signs quite early on that this wasn't what had happened. It was pretty obvious from quite early on that this was a compromise with Twitter itself. And not surprising that Twitter have come out and said that this was caused by social engineering, that some of their employees were targeted with social engineering, and their accounts were taken over. This meant that the attackers could gain access to internal tools. They could change then people's passwords. They could reset passwords, turn off 2FA, get into people's accounts, and then tweet as if they were them. So there we've got social engineering affecting, one of the biggest tech companies in the world and having this huge public impact. And we're still to find out more about it. There has been some speculation that a malicious insider was involved. Who knows? But for now, what Twitter is saying is that that was social engineering. And there are many, many, many more examples out there of social engineering and the damage that is done to companies, but also to individuals.
Yeah, I mean, I've been doing social engineering for ethical reasons, for helping companies become more secure for many, 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 many years. And it's always astounding to a lot of people to learn that you can spend billions on your technical infrastructure and your defenses, but someone like myself can walk in and literally pick up the servers that contain your data and walk out of the building, or whatever else is valuable to that company. Social engineering is one of the most powerful attacks that you can do, and it's so easy to do, especially over the internet. Physically in person, it's a lot harder. It's a lot more impactful though when it does happen. So yeah.
I was just thinking about the example from, was it a year or two ago, where I want to say it was in Kuala Lumpur, where a guy walked into a bank and he was just wearing like shorts and flip-flops, and he had a bit of paper, and he said he was there to like test the fire extinguishers,
I think, yeah.
And they didn't let him in, but he just like hung around until he could basically tailgate his way into the safe. And he stole, I think, equivalent of about 150,000 pounds or dollars.
It wasn't a vast amount, but he could only carry so much. So.
Yeah, he just shoved it in his backpack, and he went out. And what's interesting is he went out, and then he had this really calm chat with the security guard, just playing it totally cool with a bag full of cash. Basically, social engineering.
Incredible. Okay, all right. So we're coming quite close to the end, so we need to cover what else is
SQL.
there. SQL injection. That's the one. Okay, this one's slightly easier. So first of all, what is SQL? Before we get to the injection part, SQL is structured query language, and it's a language for talking to and with databases. So you get NoSQL databases, you get SQL databases. SQL is just a way of communicating and saying, give me everything that matches these things or does this, or filtering, so that you can get the data out that you want. It's like very much like filtering a Excel spreadsheet, right? Something like that. So SQL injection is taking advantage of the I don't want to say formatting, the language. What am I trying to say there? How you
the methods,
the phrasing of it. I can't think of the word right now. I should have thought about this a little bit more. So, oh my God, it's totally gone out of my head. Right, anyway, so if you have a website that generally is database driven, and it contains people's like usernames and passwords and date of birth, etc., something like MySpace or Twitter or something, will have a database as a backend, and it's generally a SQL database, right? Like I say, there's NoSQL databases as well that you can also inject into those. We're talking about SQL databases. And so when you put in your username and password to log into a system, that goes off and does a check against the database. If the database if the website hasn't been written correctly, so that you're filtering out what the user has put in, because you should never trust what the user is giving you. then what you can do is start to manipulate the structure of that query in order to bring back more stuff. So instead of just like, okay, I want to see all the widgets that begin with foo, it'll be like, I want to see all the things that start with foo and everything else in the username and password database table. So it starts to bring back more data than it should do. So SQL injection is really good for basically taking loads of stuff, getting information from a database that you shouldn't be able to. The more scary one is when you can write to that database or you can delete from that database. We've had some really massive attacks over the years where people have just dropped entire tables, entire companies' data has just been wiped off the face of the earth, and because they haven't got backups, that's it, it's gone. It's a really devastating attack, and it's one of the most prevalent attacks on websites even today. So it's actually part of the OWASP top 10. We spoke about that in the last episode, I believe.
We did. Yeah, we did.
So SQL injection is one of the biggest attack vectors that we're seeing still, and it's been around for many, many years, and no doubt it's going to be around for many, many more as well.
Yeah, people were really shocked. I remember in 2015 when there was the TalkTalk incident.
Oh, yes.
I think the third that year. And it made massive headlines, and that was SQL injection. And again, at the time, there was lots of speculation, who was behind it and stuff. 150,000 customers' details were posted online. I think it was about 16,000 financial, details of finances for 15 or 16,000 people, made huge headlines. And that came down to SQL injection. And it turned out it was basically the vulnerability was found by a teenager. He admitted that a year later. And he was basically showing off to his friends, found this vulnerability, posted about it online, and then other people started taking advantage of it. And it led to lots of problems for TalkTalk. I think they've said it cost them £60 million. Lost, I think, somewhere around 100,000 customers, and they were given the biggest fine up until that point by the Information Commissioner's Office, £400,000, because they had failed to have adequate security.
Syntax was the word I was looking for earlier. Syntax is the grammar of a programming language. So they all do the same sort of things, but how you write it is the syntax of how you do that. And because of the way SQL is written, you can mess with the syntax of it and inject code into it that you shouldn't have. There we go. I got there eventually. Just had to think about it for a bit.
And I've got to mention that everything we've gone through and much more is going to be in my book, yes, which was a little bit delayed because of some issues with publication because of COVID-19. It's now going to be published on the 10th of September in the UK and the rest of the world, 28th September in the US and Canada, yes, and amongst loads of other stuff. It covers these vulnerabilities, and I think all of the case studies, apart from Twitter, which
it covers such a vast range. It's like a small encyclopedia of cybersecurity.
Yeah.
Great book.
And we're going to be back in a few weeks for the next episode of Chatter Overflow,
yes,
where we're going to talk about vulnerabilities and how to prevent them. So what we've tried to do, we are, yeah.
Okay.
Yeah, we are. What we've tried to do today is outline some of the kind of biggest fundamental vulnerabilities and threats. And when we come back next time, we're going to talk about how to prevent some of this stuff, because obviously in cybersecurity, that's what we're trying to do.
Yeah. Okay. I think that's it.
In the meantime, find us on Twitter at SciGenterHQ. We've recently got on Instagram. Find us on Instagram at SciGenterHQ. We're also on LinkedIn. Follow us on our YouTube channel. Ask us questions. Share some of your thoughts, and we'll look forward to seeing you again soon.
I've got to do the like and subscribe thing. There we go. And hit the little bell as well. That's another thing people say, isn't it?
You're a proper YouTuber now.
Exactly.
Thanks everyone for
joining us.
Thank you everyone
for joining us.
See you again
and
soon.
We'll see you soon.
Bye.
Bye.